Okay. So I'm going to be doing the Breeding Bunnies lab activity because I know a lot of us randomly don't have access to different colored items, whatever. But luckily I do, and I have 2 colored beans. I have this white bean, or a black-eyed pea, it's actually, and then this black bean. And so for our experiment, on my laptop right here, I have the Breeding Bunnies Lab post lab on here. And then I also have the procedures pulled up so that I can do the experiment for y'all. What y'all need to have pulled up is the post lab. Looks like this. It says at the top right, the combination of your item necessary for all possible genotypes. So for me, I'll go over that, and then the data table is what y'all will be filling in on as I'm going. But here's the data table y'all will be filling out real time as I'm doing it, so you can just keep little tally marks and then go and count them later. And then further on down, the post-lab conclusion questions you will do on your own. And then the analysis, I'll go over that at the end. So, the point of this lab, like the background from the pre-lab, we know that we have this population of bunnies in England. And what you found out about England is that it's pretty mild, like it doesn't get super hot like here. And it doesn't get super, super cold. It's not like it's snowing all the time, but the weather is kind of colder. So in this population of bunnies, there is a recessive trait which makes the bunnies furless, or naked as I called them, hairless bunnies. So that genotype, if it's the recessive genotype, or if it's the recessive trait, then the recessive genotype is little a, or whatever letter. In this case, we're using S for fur. And then, is this trait harmful or helpful? These are the questions from your pre-lab. In this population, so in England where it can be kind of cold, obviously the hairless genotype or the hairless phenotype is going to be harmful because the whole point of fur is to keep you warm, and if they don't have fur and it's cold, that's not good. So it's a harmful trait. And what will happen to hairless bunnies when the winter comes? You know what's going to happen. They're going to die. And then you had your hypothesis. For those of you who turned it in, I looked over it, and most of them looked good. Okay, so I have my 50 items of one color, 50 items of another color. I have a paper bag. I have 4 bowls or cups here. And then instead of sticky notes, I just marked on my cups because it's fine. Okay. So for the procedure, it says you have 50 black beans and 50 white beans in my bag. I've already counted them out before this, and there are 50. I double checked. There are 50 of each, so 100 beans total. But if we think back to how many alleles we need for this trait that we're looking at, we only need 2 alleles. So if we have 100 alleles or beans in the bag, we can get 50 individuals. So we'll know we did it right if I get that. Okay? The bowls are labeled as follows. And then step 3 on the procedure said the rabbits reproduce blindly. So the rabbits, when they reproduce, they're not like, ooh, like that rabbit looks pretty cute. Like, they don't think like that. They're just like, oh, okay, there's a rabbit that I can mate with. And so that's what I'm going to do. I'm not going to try to select the alleles. I'm just going to pick them out randomly like it would happen in nature. Pick out 2 beans at a time. These 2 beans, again, represent the 2 alleles for the trait. Either big F, big F, big F, little f, little f, little f. And we'll get to this cup in a second. It says repeat it until every allele is gone from the population or every bean is out of the bag. and in one of these cups. And then it says that big F, and big F, little f rabbits survived because these two phenotypes, if they have the dominant trait is fur. So these two are going to survive because they have fur. But then this one, little f, alleles are going to die. So then I'm going to put them in this graveyard cup. Clearly, it's the graveyard cup. They died. And the alleles are no longer in the population. Okay? These bunnies, if they're dead, they cannot reproduce. So these alleles are gone. And then it says repeat for 10 generations because bunnies can rapidly reproduce. And then we'll look at the results. Okay. So I'm back to the Breeding Bunnies Lab post document. And it says write the combination of your item necessary for all possible genotypes. So if you have not done this, and most of you I'm assuming have not, when it says big F, the big F allele for us in this experiment is going to be the black bean. So if you need a big F, you need 2 black beans. So you are typing 2 black beans into where it says big F. Big F, little f is 1 black bean and 1 white bean. And then the little f are 2 white beans. Okay? So I'm going to do it for the first generation. I'll tell you which alleles I pull out, and then you'll see me put it in the cup. And you should be recording it in generation 1. Okay? So our first 2 beans, ooh, little f, 2 white beans. Little f. I might speed this up and you just have to look at which cup I'm putting it in. Ooh, big F. And these are mixed up really good. Trust me, I'm doing this right. Little f. This is not looking good for the population. Little f. Big F. Big F. Big F. Big F, little f, a heterozygote. Oop, big F, little f, little f, big F, little f, little f, little f, big F, big F, little f, big F, little f, I'm just getting tired, big F, little f, big F, little f, little f, big F, big F, big F, little f, big F, little f, big F, little f, big F, big F, little f, big F, little f, big F, big F, big F, big F, big F, big F, little f, little f, little f, little f, big F, little f, big F, little f, little f, little f, big F, little f, big F, little f, big F, little f, big F, big F, big F, little f, little f, little f, little f, little f, big F, little f, big F, little f, little f, little f, big F, little f, big F, big F, We're almost done with this first generation. Big F, little f. Big F, big F. I think those are the last two. Big F, little f. Okay. I don't have any beans left in this bag. Okay. See how fun this is. Be a lot funner if we were in class together, but I'm with you all in spirit. Okay, so now if you were counting as I went along, that's great, but to double check, I'm going to count and I'll tell you how many of each we had just to make sure. Okay, so on generation 1, big F, number of big F individuals, there were 14 individuals. There were 28 beans, but there were 2 alleles for each 14. There are 14 individuals. For big F, little f individuals, there are 22 individuals, or 44 beans. And then number of little f individuals, 14, or 28 beans. So, pretty happy with that result. That's about what we expected. We should expect to see more big F, little f individuals because Punnett squares. And then to double check, let's add these numbers together and make sure we get the correct answer, or 50. 22 plus 14. Yay. Okay, so everything worked out. And then the next column on here says number of big F alleles. Okay, this might be kind of tricky to think. We could go and count each black bean, or we could think back to, okay, so over here for big F individuals, how many big F alleles are in this genotype? 2. So if we had 14 big F individuals, then we have 28 big F alleles. And then for our heterozygotes, we have 1 big F per individual. So then we just take that number, 22. So we take 28 plus 22, and we get 50. Great, let me type that in. Let's do the same thing for number of little f alleles. So little f's, there are 2, so we multiply that number of individuals times 2. So 14 times 2, 28. And then in this, we only have 1 little f per individual. So again, 22. And looky, we get 50, which is what we should have because we started off with 50 beans of each color. Okay. And so then the next one says total of all alleles. We started off with 100 beans. 50 plus 50 is 100. Okay, and then right now, don't worry about those 2 columns that are kind of gray. We'll do that at the end. Or you'll do that at the end. Okay, so now 3rd generation, we think back to the procedure. These bunnies survived. These bunnies survived because even though they have a little f, they still show the dominant trait, so they survived. But these bunnies had no fur, and in the winter, they died. So they are no longer in the population. I'm going to put these alleles back in the bag, and we're going to do it again. Okay? Okay? And then, okay. So now if you think about it, I want you to kind of think about, I'm not going to tell you until in a minute. I want you to think about the number of what's going to happen to the number of big F alleles throughout the experiment. So the big F allele, the black bean, and what's going to happen to the number of little f alleles throughout the experiment. Okay? So I'm going to do this again for generation 2. Second line there. If you're counting while I go, that's great. If you just wait till the end, when I count them again, that's also fine. Okay? Big F, big F. Little f, little f. Big F individuals. 14, big F, little f individuals, and 4, little f individuals. Okay, so again, these individuals survive. These are killed off in the next winter, or the same winter, I guess. They reproduce fast, so they're dead. And then the population of big F can stay alive and reproduce. Big F, little f can stay alive and reproduce. Okay, so now let's look at the number of big F alleles that we got. So we take the number of big F individuals and multiply that by 2. So 18 times 2. And then we add number of big F, little f individuals, because there's only one allele in each of those. So 14 is 50. Crazy how that works. And then the number of little f individuals, we take, or the number of little f alleles, we take the number of little f individuals and multiply it by 2. So that's 8. 4 times 2 is 8. Plus the number of big F, little f individuals, which is 14. So we get 22 big F, or little f alleles. Sorry. Okay, and is that kind of what we expected? Well, what did you expect to happen to the big F alleles? That number should stay the same, because if they're not coming in or leaving the population and they're not dying off, then that number of alleles is going to stay in the population. But the number of little f alleles is going to decrease because they are dying and no longer in the population. So keep that in mind. The total number of all alleles now is, I can do that in my head, 72. Okay. So moving on to generation 3. Here we go. Okay, number of big F individuals. $20 big F individuals. Okay. $10 heterozygotes, and then 2 of these. Okay, so if we look what happened from the second to the third generation, the number of big F individuals increased and the number of these 2 decreased. And why is that what we should predict, or why does that make sense? Because as more of the little f individuals get killed off, that allele isn't in the population, so it's harder to get these for sure, doubly hard to get these. It's hard to get these, but we have the same amount of big F alleles. Okay, so the number of big F alleles is 20 times 2, so 40 plus 10, 50. Number of little f alleles is 10 plus 2 times 2, so 14. And the total number is 64. Okay, we can predict that that number will keep going down as some die off. So these 2 individuals are dead. The big F individuals get to reproduce. The big F little f individuals get to reproduce. And here we go for generation 4. Okay, number of big F individuals. What do we think is going to happen with that one? What trend do we see so far? Let's see if it stays true. $22. $6. And 2. Okay, I will let you calculate the number of alleles for each and the total number of alleles, because I told you how to do it 3 times now. Okay, so these 2 guys are dead. They get to stay and reproduce. They get to stay and reproduce. Now we're on to generation 5. Okay, for generation 5, we have, oh, I messed up and there should have been another heterozygote. Okay, for this one we have 22, 6, and none. So no one dies that season. Okay. Zero, so y'all can do the number of big F and little f alleles and the total number of all alleles. I'm going to go on to generation 6. They survive and reproduce. They survive and reproduce. Okay, there's generation 6. Let's see what we get. We got 22 again. 6 and 0. Okay. Again, do the number of big F, little f alleles, and total alleles. So we're going to go on to generation 7. They get to reproduce. They get to reproduce. Okay, let's see what we get. Crazy, unexpected. We got 21 big F individuals. So let's see how many big F, little f we got. Okay, that's good. That makes sense. We got 7 heterozygotes, and again, 0 big F, little f. I think you're getting the hang of this, but we're going to keep going. To generation 8, they get to reproduce. They get to reproduce. 22. Six. Okay, on to generation 9. Let's see if we get something different. $23 individuals. Okay. Big F, little f. 1, 2, 3, 4. And then, super excited about this, we have one big F, or one little f individual. And then, RIP, they died last generation, 10th generation. They get to stay and reproduce. They're alive and they get to reproduce. And then they died. Okay, let's count. Big F, we have 23, 4, and 0. Okay, so that's our 10th generation. What you need to do is go figure out the number of big F alleles, the number of little f alleles, the total number of all alleles, and then for the gene frequency of big F and of little f, remember the definition of frequency is how often something happens, basically. So a gene frequency is how often a gene is in the population, okay? So down here it tells you gene frequency, what it is, and how to calculate it. So you will calculate it in these columns for all of them. But I just kind of want to analyze the data with you and to kind of look over it. In general, the general trend for the big F individuals, we can see that they increased. Big F, little f individuals, they decreased. And then clearly these all decreased. But I don't want you to just think about these as like beans in a cup or whatever. Think about them if they are an actual population of bunnies. Okay, so in the first generation we had 14 furless bunnies. We had 14 furless bunnies, and then obviously they died off, and then from there the population just kept decreasing. So over this period of 10 generations, or period of time, what happened to the phenotypes of the bunnies? Did individual bunnies change? Did individual bunnies say, uh-oh, I have this genotype and I can't live here, so I'm going to have to grow fur real fast? No, you can't do that. They can't go and get a nice little fur coat. The bunnies can't do that. So they died. They also didn't really have the option to leave the area. They couldn't really change. Like, bunnies are bunnies. They're going to do what they do. If they're born in England, they're going to stay in England. They can't, they can't adapt, or they can't adopt, rather, other characteristics of other organisms. They can't, hibernate or anything like that. They are just going to die. If they don't have what they need to survive, then they're going to die. Where was I going with that? Oh, so over a period of time, we did have some of these bunnies, but then as they died off, obviously, our population started to look more furred. So if we had these 14 furless bunnies, they can't go other places. They can't grow fur. The individual cannot change their genotype or their phenotype, really. They can't grow fur, so they have no option other than to die. And if they died, did they get to reproduce? Did I ever put these back into this bag? No, because they don't get to reproduce if they're dead. So the only ones that are reproducing are these that survived. Okay, so if you think about what the population of bunnies looks like over a period of time, they started off with some furless bunnies, but over that period of time, those 10 generations, most of them, well, all of them, actually, even into our 10th generation, all of them are furred, okay? So keep that in mind. Don't just think about it as big F, little f. Actually think about the bunnies. Actually think about what we're trying to do here. Talking about who's going to survive and how traits can be beneficial or harmful, okay? So go ahead and finish the data table. You will answer the post-lab conclusion questions, and then you'll analyze the graph that you make of the data, okay? Don't forget, think about what's going to go on the x-axis, which I said kind of a few times, what's going to go on the x-axis, what's going to go on the y-axis, and then what type of graph it's going to be. Hint, it is not going to be a bar graph, okay?